perfectly elastic collision. Here we will classify the whole types of collision in three parts: perfectly elastic, perfectly inelastic, and in between, that is known as imperfectly elastic. Elastic collision means there is no loss of kinetic energy. Kinetic energy remains conserved in this process. Kinetic energy, that is equal to half mv square. So what is perfectly elastic collision? In which there is no loss of kinetic energy. In fact, this is possible when collision takes place between the fundamental particles like alpha, beta, neutron, electron. Their collisions may be dealt as perfectly elastic. Now, E equal to 1 for perfectly elastic, and you know the definition of E, that could be written as delta V equal to minus delta U. Relative velocity after the collision, that will be V1 minus V2, and this before the collision, you might say V1 minus V2 equal to minus U1 plus U2. You have one equation. Simply on the basis of the value of E, we get one equation here between the two velocities. Now you know momentum is conserved for any type of collision. That's a general law. There you need not bother whether it is elastic or inelastic collision. So if we apply the conservation of momentum, it will be m1u1 plus m2u2, means the momentum before collision and the momentum after collision. You are considering only two objects, before collision and after collision. Suppose one condition is also applied there, means the two bodies are having equal masses. Masses would get cancelled, and what remains is u1 plus u2, that's v1 plus v2. We have to combine the two equations. Better you put here right side, you see v1 plus v2, that's u1 plus u2. This gets cancelled, this gets cancelled. This is 2v1 and this side is 2u2. Say u2 equal to v1. One very important result. In simple words, you can simply say the velocity of first body after the collision has become equal to the velocity of second body before collision. What is this process? The velocity of first has gone to the second body. This is what we call exchange. So we have to remember that when elastic collision takes place between two bodies of equal masses, there is complete exchange of velocity. And why velocity only? You are saying that mass is equal. Velocity is getting exchanged and mass is same. That means you can say there is exchange of momentum also. There is exchange of kinetic energy also. Now let's be generalized. When the elastic collision between bodies of equal masses takes place, we might say in general there is exchange of momentum, kinetic energy and velocity as well. If this case is applied to one very rare and interesting situation, that one body is at rest. Somebody comes and collides with it. What's going to happen? If they are having equal masses, then it's a very clear cut. The first body will stop and second body will start moving with the velocity u1 because they have exactly exchanged the velocity. Like you just hit one ball with the other. This will gain the same momentum as it had. So in this case, you can say one was at rest, other came and hit, the second starts moving, first comes to rest. This could be applied to a more general situation, say a quite heavy size object. Here the size is not important. When I say heavy, it means mass. Mass is heavier. I'm not talking about the size. A light body goes and hit with the heavier body at rest. What will happen? This body will return, bounce back with the same speed, whereas the velocity of second that was already at rest and is heavier, that will remain as it is. First body that was lighter will return back with the same and opposite velocity. Again, I reiterate that in this discussion, when you say heavier one is not affected by the collision and the lighter one has returned or bounced back with the opposite velocity, in this condition size is not important, only the mass is important. For example, I quote here two examples from your practical sport life. You see, billiard ball, when one is at rest and other ball comes rolling and hits this, then the first one will come to rest, they'll exchange the velocity, and the second that was at rest will now start moving with the velocity of the first one.